Welcome back. In this video, we are going to study about threaded binary tree. Already we have seen what is a binary tree, what are different ways by which we can traverse it. We have seen in order, pre-order and post orders, and we have seen different operations we can do with a binary tree. But threaded binary tree is slightly different from ordinary binary tree, where you have something called thread. So threads are nothing but pointers with a small difference. So normally in linked representation of binary tree, what happened is there are more null links than actual pointers. So wherever there is left and right subtrees, wherever there is left and right children's or child, we are going to have null links. So we are going to waste lots of spaces. So what we do is these null pointers or null links are going to be replaced with a pointer called threads. So which is going to point to the other nodes in the tree. So wherever there is you find there is no more child for a given node, you are going to represent that using a link which is null. So what we do is we are going to replace this null with some other pointers which will point to the other nodes in the tree. Okay, so if left child is null, what we do is we are going to replace it with in order predecessor. So for example, if you take h, so h will be represented like this. So the middle part is h, and this is null and this is null. Now what it says, if ptr left child is null, so think that this is a ptr, so left child is null. What happened? Which should be replaced with in order predecessor. When you travel a tree, first you have to find how we can travel a given tree in order. So when you travel this tree in order, h is going to be the first node in order. You have to visit leftmost one, then you have to visit the root, then you have to visit the right. This is going to be HDI. But for the given node H, there is no in order predecessor, so which is going to point to a dangling point H. Now think that if the right child is null, right part is null. So again, if you take H, H does not have any right child. If that's the case, you should see that this part is replaced with in order successor. So what is the successor for H? So if it is in order, the first node is going to be H, then D. So for H, the successor is going to be D. See, we got this. Take I, left is empty, left part is empty, and even right subtree is empty. So if it is left is empty, you should point to the in order predecessor. So for I, predecessor is going to be D. You should point to that. And if right child is null, again for I there is no right child. So right child is null. It should be replaced with in order successor. For I, which is successor, B. So when you take the given tree and if you traverse, you will be getting the order as H, D, I, then B. For I, in order successor is going to be B. So we can find a thread from I to B. Same way, you can find a thread from I to D in the left side. From H to D, there is a thread. From H to null, there is a thread. But see that which is left and which is right. Right? So the thing is, how do we differentiate? How do we know that is it a thread or a pointer? So to make it sure that what we do is we are going to use two more segments in the given node. One is left thread, other one is right thread. If the left thread is true, meaning is the left child has got a thread. Same way, if it is false, the left child does not has got a thread. That means the given node has got a right child. Right? That's the meaning. If PTR left thread is true, then PTR left child contains a thread. Otherwise, it does not contain a thread. Same way, if PTR right thread is true, so this is a right thread. If it is true, PTR right child contains a thread. Otherwise, it does not contains the right child. So this left thread true or false is going to tell you whether it has got a right child or left child or not. So we are going to make a small change in the structure. So before the structure was with three members, one for the left child, other for the right child. So we have got left child, we have got right child and data. Now, as I told, we have got a little different structure where you can find the node with five members. Which are the value addition to this? We have left thread, we have right thread. So this also we are going to add to the structure. So rest everything remains same, and thread tree is the new type which we have created. And in the new type which I created, there are five members. What are the additional members? Left thread and right thread. So let us see the memory representation for this. So this is what the given tree. We have a tree with 8 nodes. Sorry, there are 9 nodes. So we start with the root, and this is going to be the PTR. PTR will have the value, or the pointer will have the value of the root node. Now, so look at this. H does not have any left child, so H will point to the in order predecessor. For this H, there is nothing. Same way, I. So H is having a. So if you visit this in order, you will be getting H, D, I. Then you will get B. This was the order, right? So H left child for this there is no predecessor, so which is going to remain as it is. Right child will point to the in order successor. So for H successor is D. So you can find an arrow mark. So same thing we have represented here. So what changes we have made with D? This is D, and see F. F means the left child has got some value which is not a thread. That means the D has got a left child. So this F is going to indicate whether it has got left or right child. So if the right part is F, that means it has got a left child. If it is true, look at this. You can look at the node E, where you can find in the thread part two T's. Look at E. This is what your E. E does not have left and right children. So you can find T. Who is true here? Threads are true. That means your node E does not have any left and right children. Look at F. You can find F. So F also does not have any left and right children. So we can see T here. T is nothing but this part is filled with some value that is not for the right child and left child. You can find 2F. If you look at C, where you can find 2F, that means which has not got left and right thread. What does it mean? Which has got left and right children. See, C has got two children, F and G, and we are done with this. And the previous case, there was something called dangling pointer. I told H will point to some null values. To avoid this, you have taken a node called root node, which is going to avoid this. So this is what our actual node, which starts with A.